This section is going to be on the spanning tree protocol. You ever wonder when you connect up switches in your network that you see that it takes an extremely long time for your ports to initialize? Well, you can blame part of that on the spanning tree protocol and the election process that's necessary for switches to coexist. Spanning tree basically is a protocol that does two things for us. First of all, what spanning tree does is it allows us to connect switches in an environment and prevent that environment from having what we call router switching loops. Switching loops are when packets are entered into a loop and there's more than one way to get from one path to another, and they endlessly circle it within that loop. So we have to eliminate that process within our switch environments. The second thing that spanning tree does for us, though, is that it allows for us to have redundancy. So there are many times you're going to want to take a switch and have multiple connections from one switch to another, which would result in a switching loop. But in this case, what it's going to do is going to automatically open that connection for us and prevent that loop from happening. Now, if we have a failure somewhere along the line, the spanning tree protocol will go in and heal that connection and provide that redundant connection so that we're up, back, and running. So basically, that's what spanning tree does for us. It provides for redundancy while preventing us from having switching loops. All right? Basically, the concept of the algorithm for spanning tree is based off an election process. And the election process, basically what happens is that we have one switch that's going to be elected the root. So the term spanning tree comes from this idea that we are going to create this spanning tree that's going to have one path up all the way up through its root and up through the trunk. So the term spanning tree basically means we can continue to span this tree, but is going to ensure that we only have one path through this entire environment. Okay, so how does spanning tree work? Well, basically what's going to happen is when we initialize these switches, we are going to have an election process that occurs. And so you're going to start to see the switches and the port lights start to change colors. And as they're changing colors, basically what's happening is they're exchanging information about their spanning tree priority or their MAC address, which is going to be used to determine which one is the root switch. All right, so basically what happens is this. Out of the box, all of these switches basically will have the same spanning tree priority. If we don't go in and do any type of configuration on them, they'll all have exactly the same spanning tree priority. So what would happen is the switch that has the lowest MAC address would be elected to root. And all the other switches then will try to establish the closest, shortest possible path back to that root switch. Now we can actually intercede because we don't want any switch to be necessarily our root switch. We don't want a switch in an access closet somewhere to be our root switch. So what we can do is we can actually go in and put in a spanning tree priority, assign a spanning tree priority to the switch that we want to be the root. So we're going to give it a lower priority than all the rest of them, and it will then become the root switch. It will go through a new election process and it becomes the root switch. All right, so what we want to do with this is actually go in and experiment with how spanning tree works. And we can do this with Packet Tracer. So if you go to Packet Tracer and you pull out 4 similar switches, so we go and pull out 4 similar switches and we connect them. Well, how do we want to connect them? Well, why don't we just connect every switch to every other switch? Now we have tons of loops out here. We have all kinds of loops going to every switch, right? So how is spanning tree going to react to this? Well, when you connect all of these and make your connections, and remember we have to use the right type of connectors. We're going to use crossover cables between all of these connectors. You'll see the spanning tree algorithm in effect. You'll start to see the port statuses change, the lights change, and ultimately after about 45 seconds it will settle out. All right? When it settles down, the election process has been completed. And what we'll end up with is one of these switches being elected as the root switch. And so if we looked at this situation, which one of these switches would be the root switch? Well, it looks like we have 2 good candidates, right? We have switch A and we have switch C, which would be good candidates for the root switch. Why? Because all of their switches are on. So it's a good chance that one of them 2 are the root switch. So how do we know which one is the root switch? Well, if we take a look at the connections to each of them, you can see that switch A is connected to switch B. Even though the port on A is on, you'll notice that the port on B is off. So we don't have a direct connection between A and B. Well, that's a good indication that this is not the root switch. So let's take a look at switch C. Take a look at switch C. Its connection from C to A is green on both sides. You'll see from C to B is green on both sides. And you'll see that C to D is green on both sides. Only one switch will have that circumstance. That has to be the root switch. Okay, and we could go in and actually change these. Let's say that we wanted switch A or switch